Okay, for number one, determine the values for n for which a following infinite series converges, and then find the sum of the series. We're looking at, looks geometric. So let's go to the whiteboard and talk about that. And the first thing I'll do is just write down, the geometric series that you should be familiar with. And let me get my pen out, make sure I have my pen first off. Yeah, I do. So if you have a geometric series, it's going to be 1 plus x squared, x cubed, plus yada, yada, yada. This would equal 1 over 1 minus x, provided the absolute value of x is a proper fraction. Let me just review that with you. And again, the way you were given this in Math 120, may not have been using the letter x, but anyway, you gave a finite one, it's x to the n. You multiply both sides by x, you got x times s, x squared, x cubed. Doing a little bit of review here, x4 plus yada, 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 x to the n plus 1. You subtract it, and what'd you get? You got s minus xs equals, well, looking at this thing, there's a large number of cancellations when you're doing this over here. What do you get? 1 minus x to the n plus 1. Then what do? You factor out the s, and you get 1 minus x. And this is the finite sum, by the way. 1 minus x to the n plus 1 over 1 minus x. And I'm sorry, I went too quickly there. I realized I was thinking forward, but shouldn't have done that. And then I'll divide by 1 minus x. You get s equals 1 minus x to the n plus 1 over 1 minus x. And then your teacher said, oh, this is a finite sum. This is Sn. Maybe you should indicate that by putting this over here. This is a finite sum, Sn. And you want the infinite sum, you let n go to infinity. And that's going to be of Sn. And that equals, under certain conditions, it equals 1 over 1 minus x, which we stated up here. Now, what's the condition? The condition is that this thing shrinks to 0. And the only thing that shrinks to 0 is if x is a proper fraction. So let's write that condition out again. And that's the absolute value of x less than 1. So let's write down this series. I got to wake my computer up because I got to look at it. And it looks sort of geometric. I'll put this over here. This is k equals 1 to infinity. And what do you get there? You get 1 over n plus 1 to the k. And I'm going to write this a little differently. I'm going to write it as the sum, k equals 1 to infinity. And I'll write this as 1 over n plus 1 to the k. All right, same meaning. Now again, if you wrote this down, you'd get the same thing you get over here, which is 1 over n plus 1 to the first power plus 1 over n plus 1 to the second power, yada, yada, yada. Now I want to point out, this does look a little different than the other one, but not substantially so, all right? Now what do I mean by that? The other one we wrote down, I'll write this over here, with the k, by the way. K equals, let's see, 0 to infinity. What does that look like? It looks like, again, going back up here, this would be x to the k. So you get x to the 0, x to the 1, x to the 2, yada, 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 which is really 1 plus x squared plus yada, yada, yada. Well, the one above sort of looks like that, but it's missing something. It's missing a term 1, all right? So I'm not too concerned about that. I mean, I could write down, 1 plus this. I'll write over here 1 plus the sum, k equals 1 to infinity. And this would be 1 over n plus 1, k. And that would be geometric now. What do I mean by that? It's 1 plus blah, 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 blah. So I'm going to say, I could certainly make it look like that. I'm not too concerned about that. It's certainly geometric. But what I want to do is write the sum down, all right? I want to write the sum down. Now, before I do that, I want to claim that the common ratio, in this case over here, something has to be held accountable at this point. So I'll write that down for you. What the common ratio is the absolute value. This is like the x, by the way. 1 over n plus 1 must be this. Let's write this down. And I have to solve this inequality. It's going to be 1 over the absolute value of n plus 1, less than 1. I'm going to say n can't be minus 1. And I'm going to try to solve this inequality. And what do you get? It's pretty simple. You get this over here. And what does it say? The absolute value of something has to be greater than 1. Well, that's kind of two different conditions, by the way. So I'm going to say, looking at it, and again, we're looking at this over here. We're trying to solve this. And what does it really say? The absolute value of this thing has to be greater than 1 from the origin, which means this thing could be less than minus 1 from the origin, or this thing here could be greater than 1 from the origin. What do you get up there? N less than minus 2, or n greater than 0. So I have a series of numbers over here. And if you were to put this down, I'll just write this over here. It's sort of like intervals. Minus 2 and 0. N greater than 0. Could be over there. And over here could be less than this over here. All right? So if we put intervals down, n could be on the interval from minus infinity up to minus 2. Union, let's see, 0 to infinity. All right? Now what's the sum? Let's write this down. Right, and this often, people say, what's the sum? Let's write this down. If I had the sum, and I'll put k equals 0 to infinity of this thing over here, which is 1 over n plus 1 to the kth power, that would be 1 minus the common ratio. And what's common ratio? 1 over n plus 1. And I'm going to multiply top bottom by n plus 1 next. It just doesn't look right to me. And what do you get? N plus 1. And then on the bottom, what do you get? You get n plus 1 minus 1. And let's write this down. So you get n plus 1. And on bottom, what do you get? You just get n. So what do you really get over here? You get 1 plus 1 over n. Now, I hope you realize that this is not the original series, but it's really close to it. And someone says, what's missing over there? The thing I wrote down was, I wrote down k equals 1 to infinity. 1 over n plus 1 to the k. What's it missing? It's missing the first term. So just take away the first term from this, which is 1. What do you get over here? 1 over n. And we're done. Again, the condition here is n has to be a number from minus infinity up to minus 2, union 0 off to infinity. Any finite number in the interval. Right, that was number 1 in the contest, and we'll go to number 2 in a moment. Thank you.